Welcome back, everyone, to the Pink Floyd stage. I am here now with Pavel Veller, and this is what I know about him. Pavel is a polyglot technologist and a strong leader with 20 plus years of diverse experience building and releasing complex software systems and products for the web using Java, C Sharp, Ruby, JavaScript, and everything in between. At EPAM Systems, as a CTO of digital engagement, Pavel has been driving digital technology innovation and R&D aimed at helping EPAM's clients with their digital transformation efforts. 2020 changed Pavel's focus to helping EPAM transform itself. And here is Pavel with Anywhere.io, a story of rapid technology transformation to enable remote and on-demand workforce at scale. Word to you, Pavel.
Yes, hello. Thank you. Thank you very much. That was a mouthful. I wish I could say I'm happy to see you all. Unfortunately, I don't see you, but you can see me, so I guess I'm happy to be seen by you all. My name is Pavel Veller, indeed. And EPAM needs probably some introduction to this audience. We are a large software services company in the business for 27 years, have been building amazing software products, services, API systems, ecosystems for different customers around the world. We're present in 31 countries, actually now 32. We have opened a new office in Lithuania, not even a month ago, I think, and have a lot of plans to grow there rapidly. I am myself from Minsk, originally Belarus, but I've spent the last 13 years in the United States, and I'm broadcasting to you live from Atlanta, Georgia. It's 5 a.m. right now, so if I look a little sleepy, that's why. And last note before I begin, typically when I present, I try to animate myself on stage. I don't know how it's gonna work with this delivery, so instead I animated a lot of my slides. If nothing else, I do hope you guys are gonna get a good show. And the best thing for you in this world is if you don't like it, you can just stop watching it and I'm not gonna be offended or even notice it. So certainly gonna work for you. But with that, I'll begin. I came to talk about Anywhere. If you go to anywhere.io, what you're likely to see and think that you're looking at is yet another freelance marketplace like that of TopTal. We're actually building a lot more. It does start with work. At the end of the day, we are a software services company. That's what we do. That's what we know how to do. And we've been growing since ever. And of course, we need engineers. We've been exploring the idea of workforce without borders for a while. But 2020 and COVID accelerated all of that. I think everything that can be done remote will be done remote, and now everybody believes it. There's no discussion. But we're building a place where people can work, learn, grow, and be part of a vibrant community. Now, you don't have to take my word for it. You can, of course, try it if you want. But B, I'll give you a little different perspective, not from where I am, from within, but a little bit from the outside. I'll have to simplify, but if I were to sort of go through options, let's call them employment opportunities for a software person, they're generally going to fall into three different buckets of type of work that you can do, a type of company that you can work for. And one can be a product, and it can be a small, B2C startup, or it can be a large enterprise building software for itself. Like we at EPAM have a large product ecosystems built for ourselves. Anywhere is, by the way, one of those products that I'm going to talk about today. And that comes with its own, working for a product, comes with its own sort of unique benefits and unique way of how that work is organized. You can be free, and that's why free in the word freelance. You can contract, you can work with the companies that you'd like to work, you can do different things in your own schedule and do it from basically anywhere. Or you can work in the services industry. That's what we do. I've been in services for 20 years. And that's like yet another flavor, right, of building software. All of this come with slight different options. What we're trying to do with Anywhere, we're trying to have all of that in one place so that with Anywhere, you did not have to make those choices and can have all of the parts at the same time in one place. And also, like I said in the beginning, not just feel like all you have to do is go and work, but have lots of education options, trainings, courses, and very, very, very large community for different interests, both like work and no work related. It'll take us some time to actually build it and make it so that it stands up to the promise, but that's what we're building. Now, I didn't come to just keep talking about what Anywhere will be. I actually came to talk about our architecture journey. This is a software conference at the end of the day, and I'm sure you're more interested to listen about how versus about what it is. And what I'm going to talk about the rest of the presentation is where did we start? Every product, every system has a beginning. We had our own, and that beginning defined a few things that happened after that. I'll walk you through up to the point of this young product having the architecture that stopped working for us and why. And then we had to do something about it, and of course we did. So I'll walk you through that transformation. We'll see about what we had to change, why we had to change it, how we changed it, and at the end, how it helped us look at what we're building in a very different way. And hopefully we'll arrive at the end to some lessons learned. I believe that what we've been through is not atypical. And I believe that what we've learned can be applied by many of you in your day-to-day work. And I guess with that, we'll get started. So let's see, where did we start? The thing about the starting point for us was that we made a mistake, like from day one. We did not start fresh. We had a system built a couple of years ago called Contribute. If you think about a large enterprise, wanting to build systems internally for different reasons with different sort of targets, let's call that enterprise open source. There's a concept that exists like that. Now, add some crowdsourcing on top. So people in the enterprise can come in, either list their ideas or list work that needs to get done. Other people can come volunteer to contribute, hence the name, and build different things. So we have this sort of software built that orchestrates that relationship, and that's called Contribute. A year later, we looked at that system, said, look, that looks good. Let's keep it running. Let's build another one. We sort of selfishly called it EPAM Plus. And that was the same sort of crowdsourced enterprise open source with the marketplace concept on top, like actual physical marketplace. And that's what we had when we started thinking about building Anywhere. And the mistake that we made was that we thought that what EPAM Plus is what we wanted Anywhere to become, with the only difference to be of being public and accessible to many, many other people outside of EPAM. And so we thought the right thing to do would be to start with that EPAM Plus to build Anywhere. Now, looking back, and hindsight is always 2020, we know that was a mistake. That didn't materialize. What we wanted Anywhere to be has rather significantly changed over time, and none of that baggage that we started with we actually got to use. We're still carrying it. It's still hurting us, and I'll talk about this some more. But Anywhere didn't start sort of from the fresh, right? We didn't start greenfield. We took a system that we had, cloned it almost literally, and evolved it into what became the first version of Anywhere. In addition to that, we had the very typical for every software project, no matter which one of those circles you're in, we had the time pressure. We had to be live by a certain date because we really wanted to. And not starting fresh probably gave us like maybe additional, less 2 weeks or maybe 4 weeks less of time. Not significant, again, looking back, but at the time felt like significant. So we just went for it. Now, technically, what we had was a big React app served at the time through a thin layer of Apache, could have been Nginx, doesn't matter. and then backed by APIs built in Java in Spring Boot, and with data sitting in Postgres. I like all databases. Postgres has a special place in my heart, and so again, we're just using Postgres. We could be using anything else really, but that's what we do. Now, I'll need to give you a little more details so that you feel better what this product does, and how it's operated and how it's orchestrated. We still do some of it. You'll see I will show you the evolution. Run most of it in containers. All orchestration of our CI, CD, and infrastructure automation happens through GitLab pipelines. I do like them. I like them. GitHub Actions, GitLab pipelines, they're all the same idea. Having your automation running where your code sits has certain advantages, and that's what we just do. We're also using Content Stack. That knowledge comes in handy a little later. Content Stack, if you're not familiar, is a very modern API-first SaaS CMS. If you heard of or worked with Contentful, Content Stack is rather similar. They're not the same. They're different. They have different sort of pros and cons. But as far as mental model, what the system is, it's very much the same idea. And because our app at the time was predominantly client-side rendered, the interactions with the CMS were pretty straightforward from the browser, from the rendering time up to get content and work with it. Now, we don't live in isolation, and our APIs actually take a little more space because of all that baggage that we're carrying. And I need to tell you a little more about the ecosystem around Anywhere. And I'll need to start with the users. You'll see that my favorite color today, especially, is orange. And we have identity access management, which is your traditional OAuth that users authenticate. And our security infrastructure from the APIs does the code for token exchange and token validations. We have 3 systems that I need to tell you what they do, because we integrate with them, and we integrate with them quite a lot. Unified profile, because we are a big multinational company, we operate in different countries. Different countries have different regulations when it comes to personal information. We need to be compliant, GDPR, Russia has their own laws. I'm sure every country has something that we need to be aware of and comply with. And we delegated many decisions about how to store and where to store personal information to a service, and that's what we're working with. Interview, as the name suggests, handles all the interview lifecycle, scheduling, notes collection, task administering, probably many other functions. And staffing desk is sort of the center of how we operate internally. Projects, people, assignments, projections, forecast, talent acquisition, all of that sits there. Many integrations are synchronous, like meaning API to API. Some are asynchronous, which means we're going to store events in a database and then have jobs in the background processing them and doing the things that needed to happen anyway. And of course, like every large ecosystem, we're running a data hub in Kafka. Many other systems talk to it, they send their data, they consume data, so we are not an exception. So that's where we live and who our neighbors are. And in a way, that integration was the reason why we started with that EPAM Plus baggage, because we got all of that for granted. It's been built. And we didn't have to engineer each one. We didn't have to think what needs to happen synchronously versus asynchronously, at least for the scenarios that were there from the beginning. And that was the only plus that we get from starting not fresh. Everything else was sort of a minus. And this is how we launched. So what you're looking at technically is what launched right before COVID. It launched mid-February 2020. We had something up before, but it wasn't transactional. So Anywhere that you can actually go in and apply, get onboarded through the process and become part of Anywhere, launched in February. And from here, very quickly, maybe in less than 2 months, we arrived at the architecture that stopped working for us. And let me tell you how that happened and what specifically we didn't like. And we probably now wouldn't have liked it in the beginning. We just didn't have the context to think about it. Because after we launched, we started growing. And the growth immediately showed itself through us building more experiences, more apps. We're smart enough not to package them into the same app that we had. So we built standalone apps. You can call them, with a fancy modern word, of micro front ends, because it's all the same anywhere. It doesn't live on the same page. It's just different apps, meaning they're different URLs technically, but it's still the same ecosystem. And these apps needed their own, well, they could use the same APIs, but some needed new APIs. We also didn't build them as part of that original monolith. We started building them separately. And you can again call them microservices. They're not necessarily micro. They are individually deployable. And this is what enabled us to run multiple teams within anywhere program or project. It depends on how you look at it. And that's really the only way and the only real good reason to start doing this. So we were doing that, not moving fast enough yet, but that's what was happening. Some of the front ends, new front ends, opted in to be server-side rendered. So we needed to have, and we introduced containers that would render, Next.js. And this is when this guy came in. Not everybody knows him, but if you happen to be sort of modern Java engineer building modern apps, meaning web apps and services and microservices, you likely know who that person is. I'll introduce him to you. His name is Hipster. And Hipster is like open source framework templating engine for microservices apps. So if you need to start with a recipe, it has them. It has sort of architectures that it recommends. It comes with code snippets and command line stuff. Basically, it's a decent starting point if you want to have someone guide you through the process. I have mixed feelings about Hipster right now, having seen the team use it. Maybe we didn't have enough experience with it, I don't know. But I'll jump forward. We sort of almost got rid of it by now. But at the time, with Hipster, we, of course, need to have a gateway. How else can we route through our APIs? And we built it. And we had a service registry for which the team opted to use HashiCorp console. And that's almost the architecture that stopped working for us, with one additional thing that I need to name. I need to tell you where it runs and how it operates. We run it today. Oh, we used to run it. I'm sorry. We used to run it at the time in our own Blue cloud. And it's technically, it runs an OpenShift. But what is our cloud? If you go to cloud.epam.com, you'll learn some about it. We started building it like 10 years ago. And there are a couple of reasons a company will want to have their own cloud. Now, I'll tell you, this cloud is not just the runtime infrastructure. It comes with a rather unique orchestrator that helps our teams provision cloud infrastructure in all three major clouds, AWS, Azure, GCP, get it financially operated by project. So, financials are segregated, the project knows its cost. It comes with built-in networking so that you can have VPCs back to our own infrastructure. Like all of that is sort of built in, simple APIs, and off you go. And it's provisioned, and then it's amazing how seamless you can get cloud infrastructure for a project. But it also came with its own compute infrastructure. So what's important for what I'm telling you is that it runs in that own compute infrastructure. So it runs in OpenShift. Excuse me. And to complete the picture and to start explaining the architecture that we stopped liking, there's one more piece I need to show you. in that OpenShift infrastructure, everything starts with an HA proxy. Think of that as a balancer. It is a balancer. It acts as a balancer. And that's what defines one of the two important planes that I'm going to talk about in this architecture. Plane number one is the HTTPS or HTTP plane. That's where all requests come in first. Like, doesn't matter, is that a static asset? Is that server-side rendered page? Is that API? Everything comes through HTTP plane. And as you'll see how I explained what happened to the architecture, capability of that plane will matter. How much can you do at that stage? And with HA proxy, you can do, well, in this case, in our case, you could do not much. You could route, but that was about it. And then the second plane is the API plane. Everything that's actually an API will go through, in this case, the gateway before it reaches any service. And the capabilities of the API plane will also define how much you can do there. So this is what we have. This is the architecture we quickly arrived at, give it a couple months after we've launched. And this is what stopped working for us. I mean, it was working, just not working good enough. And I want to now explain what we didn't like and why we didn't like it and why we thought we had to do something about it. First of all, our deployments, our releases felt very monolithic, even though the architecture itself isn't. So we don't have a monolithic front-end app. We don't have a monolithic API backend. It still felt very much like one thing. Maybe there was processes that we were following. Maybe it was how it's been sort of orchestrated, but it didn't felt lightweight. It didn't feel transparent. So it felt this, heavy and like a black box in a way things. Some of it was due to Hipster doing some things. Some of it due to the infrastructure what was running and how transparent that infrastructure could be and how stable in different meaning of the word it was. Running in a compute-only cloud, all you have is compute. Meaning if you need to do something that you don't have as a service, you have to build it. And you have to operate it, or you have to, deploy it and do something with it. So we certainly felt like we were doing things that we probably shouldn't be spending our time on, and ideally would use something that was readily available. With the API gateway that we built, following the Hipster patterns, what we could do at that stage, pretty much limitless. You can do anything because you write that code yourself, but you need to write that code. So capabilities available to you are rather limited. Like, think of rate limiting, versioning and controlling the routing to different versions of the same API. Maybe some payload transformations that you need to do. All of that is sort of not there unless you build it. And all in all, the team wasn't moving fast enough. And I'd like to specifically separate velocity from speed. We had velocity as far as metrics, executing on tasks and closing off stories and doing your sprints. All that stuff was happening, but the team wasn't moving at the speed that the stakeholders sort of expected from the team to be able to produce. And all that while at this time already COVID is happening, we're well into this sort of closed off, everything remote life. We understand how anywhere is very timely to where we live and how we live. So we needed to support rapid growth instead of sort of struggling with moving at the right speed. The thing about the struggles is that, well, in my experience, you have to look at 3 different angles at the same time. It's team, it's product, and it's technology. Team, by the team, I mean, do you have the right individuals on your team? Do you have too many of them? Do you have too few? How do you apply the talent that you have? How do you engineer things? How do you organize work? The team can be at different stages, forming, storming, norming, performing. What stage are you at? If you're not performing, how far from performing are you? What needs to happen for you to get into that performing zone? All of those things is the team. Product is all about what you're working on, roadmaps, features, strategy, tactical tasks. And if it's not in order, and in order is of course a spectrum, but if it's not in order, it's hard to make, I wouldn't say correct, but I would say sustainable. It's hard to make sustainable technology decisions if everything else is hectic. So approach to product needs to be reviewed, of course, and if need be fixed or improved. And then technology is obviously actually how you're building your software, what you're using, where you're running, how you're thinking about it, and how you're engineering it. I will not talk about the team and product today. Today, I'll focus specifically on technology, but if you guys have any questions about what we've done to the team, how we thought about what needs to be happening with the product, I'm happy to talk about as well. Because over time, we've done some product transformations, and both in how we operating it internally, as well as how the product looks and what it does. But the focus today will be technology. So I want to walk you through how from where we've been, we arrived to a very different place. I want to explain why we like it so much better, and also how we did this. So we're going to go talk about that step-by-step transformation. So we started here. We started with the architecture you have seen that I've explained, running in OpenShift in our own EPAM cloud. And what we needed the infrastructure shift as the first step. So first step was very subtle. We changed the colors. From blue, we changed them to orange. I'll do it again just to make you see that, right? So we were here, and now we are here. We literally took every single thing, and everything was in containers, lifted it from OpenShift and dropped it in EKS, in AWS. We started with lower environments first. I'll do a little quick demonstration of some of this later, so you'll see how it sort of looks when you look at it in AWS. But we just moved over from one runtime to another runtime. No changes within the application itself. The only changes were through the CI/CD and infrastructure as code pipelines. That had to change. That had to account for now provisioning in AWS. That had to account for now running in EKS versus OpenShift, but nothing else changed. We even ran for maybe 2 or 3 weeks, if not 4, ran all our lower environments, meaning all feature branches, all bug fix branches, release branches, all of that had environments provisioned in AWS, while production, anywhere.io itself, ran in the original OpenShift. So we just were deploying both ways. And we needed to do a few more things before we were ready to switch DNS for production to AWS, and I'll name them. Remember the HTTPS plane? Not much changed with this drop in EKS, right? We're not using HA proxy, we're using NLB, load balancer that AWS has. But capability-wise and what it can, or rather cannot do for us was the same. And our API plane is exactly like it was. It's the same gateway, the same Hipster pattern and approach to implementing our services. So certain things needed to change in that department first. Interestingly, though, at this time we were presented with an opportunity. We have these partners who we wanted to advertise our job postings on, LinkedIn, Jubilee, and a couple others. Remember content stack I mentioned in the beginning? So that CMS not only used for web content, it is also used for vacancies management. We started with sourcing them from our internal system up to content stack, and then promoting to the web and the rest of the pieces that needed it. The process will now reverse. The team that works with content stack liked it so much that they don't no longer want to work with the original, system that they had in house. So we're likely going to just move over to content stack and start pushing vacancies everywhere else for our regular or traditional job postings. And the thing is, like, why build your own administrative tools if what you do is sort of structured data management, and modern CMS is great at just giving you that and exposing APIs for the content that you've created, and that's what we're doing with Content Stack. So we had to build a service, a new API that will pull that vacancy jobs content and push it to all these partners. Now, we could have done it just by keep building more services like we were doing already, right there in Kubernetes and in containers. But instead, being in AWS, what we've done with this little service, with this API, we built it with Lambda and we built it with Node. So we started introducing, thanks to different runtime options, our architecture started being a little more polyglot. I had React and JavaScript, well, TypeScript to be honest, but still JavaScript all along, but it was in a different land, in the front end land, and everything else was Java and Java APIs. And with this one Lambda, we said, well, our APIs don't have to be all Java. They can easily be something else. And they can even run differently and have very different profile. And that little Lambda started the orange, I mentioned orange earlier, orange revolution for us. But that alone wasn't what was holding us back from switching DNS to AWS. It was something else. We wanted to do better at serving the front end. So we needed to go through an infrastructure upgrade. If you look at that guy, the Apache that is currently the main server of all the web experience that comes through when you go to anywhere.io, it had to change. There's no reasons to run your own web server when you're in the modern cloud, right? We wanted to be on a CDN, wanted to do a lot more advanced routing, caching, and other behaviors at that entry point. So we swapped it, well, literally just we threw it out and started working with CloudFront backed by S3 bucket. So all the client-side rendered front end was now deployed, not to Apache, but deployed to an S3 bucket, connected to the CloudFront, and that where DNS could point at and have a very different HTTPS plane. We also had at the time the API gateway, because how else can we connect to the Lambda? Because that Lambda wasn't really a push, it was a pull. The partners that I mentioned, we're not pushing, only one of them was a push. The rest of them was pull. So we give them an API and they go and pull it a couple times a day and get their feeds this way. So we needed to have the gateway, which means our API plane was no longer as simple as one, it was two, with fairly different capabilities. And what needed to happen next was the infrastructure cleanup. We, as a next step, retired the original Hipster self-built and self-written gateway. It was no longer needed. We had retired the services registry because in EKS, we could do all the routing between our services within Kubernetes. We didn't have to have anything else running on the side. So we did away with that. And architecture streamlined. And streamlined to the point of what being ready for prime time. It's at that time when we switched DNS and started running production in AWS as well, and retired the OpenShift infrastructure. And with this architecture, and I'll show you that in a minute, routing to the APIs go like this. So from CloudFront, the gateway to NLB, maybe to containers, or maybe to Lambdas, and there's more than one Lambda by now. And then routing that goes to our server-side rendered next pages just bypasses the gateway, because why do you need to send HTML through the gateway? So what I want to show you I want to show you how that looks so that you guys can get a little feel for what I just told you about. So I'm going to get out of my presentation for a sec, and I'm going to go here. And I'm going to show you what I just illustrated. Remember I told you how we're running all the environments? So if you look at, what you're looking at is CloudFront right now. And if you look at all the environments that we have, so every environment, feature environment or bug fix branch or anything has its own distribution created. But we're going to look at our main QA trunk. They're all the same configuration wise, unless what you're doing is you're also testing some infrastructure parts, then your branch can introduce different infrastructure, different pieces, but mostly they don't. So the origins that we're using from the CloudFront can be the gateway, that first hop, the yellow hop. It can go straight to the balancer. That's the server-side rendered next pages will do. Or they can go to an S3 bucket. Behaviors, there are more than just 3 because we do different things at some of these routes. We can run lambdas, and we do at some of them, that help us do different things and more advanced things right at the edge. So when request comes in, before it comes further down, something can happen. Or when request comes out and something about this want to change, that can happen as well. And that's what we do in response, we do in request, we do different things. We can, because the capability of CloudFront is like, you can't compare what CloudFront as a CDN can do to just a simple HA proxy. And if you go look at the API plane, the next layer in that architecture, you'll see it's a very similar picture. You'll see APIs for all the environments. There's many of them. And they'll again will look very much the same unless you're testing a new API as part of your feature. So you'll have a bunch of routes. Some routes will be defined and spelled out. Some will not be. They can be just behind this proxy plus. All of the proxy plus will land in containers. I'll show you. And all of them require authorization. So they're all sort of user context, and they're fronted with AWS authorizer, GWT authorizer. And you can tell by looking at integrations that many of the APIs remain in the Kubernetes, and they have to go through the balancer to land there. And some already live in Lambdas, and there'll be more of these as we keep building more APIs. So that's what I showed you, and I'll go back there with this slide. I just illustrated the routing. I didn't want to go anywhere deeper, but that's how we're running it today. So largely, the code that we had originally built still runs and hadn't had to change at all. So that code was packaged in containers, remains packaged in containers. It lives now in EKS versus OpenShift. We had to do some changes around that gateway, the Hipster pattern that we removed. So some of the code had to adapt. It basically stopped doing things that it was doing before. And from here, we now have a very clean and rather powerful HTTPS plane, and what we can do at the CDN is very different. By the way, when we relaunched the DNS, our Lighthouse, Google Lighthouse score jumped 10 percentage point just by itself. We didn't do anything. At that time, there was no optimizations to nothing. But because of HTTP2 and some extra caching and faster delivery, closer to whatever, Lighthouse jumped 10%. We have since improved it more, but that was a sort of concentrated effort to optimize. But the 10% jump in the beginning was just simple thanks to CloudFront. API, now it's a clean plane. What you guys have seen when I showed you AWS console, all of those APIs are HTTP APIs. If we need, we can always go back and start using some of the more powerful REST APIs, but we're using HTTP. And that changed the perspective. And I'm gonna tell you in a way how, and what do I mean by this? Architectures have different profiles. There's this fancy word called quality attribute, maintainability, availability, blah, blah, blah. But just think of a few things, right? Different cost profile, different performance profile, and a different availability profile too. Our architecture got a lot more orange, so Orange Revolution full swing for sure. We built more APIs. We protected through the gateway GWT authorizer, and started building more lambdas, the feed API, the search API, file upload API, and more. We started using services available in AWS, managed services, remember I mentioned. We're using Elastic. We will use Dynamo, one step away from it. Architecture got a lot more organized. We will use more of the services because why not? We can move our email sending to SES. We'll move any asynchronous and queuing processes to SQS. There's more managed services we want to use so that we didn't have to do anything else. We have a clean separation of where our APIs live. Some live, in containers, some live in lambdas, and some leverage these managed services. It's the same functionality with a very different profile. By now, it cost us a little more, but we're fine with that, and we're going to optimize the cost as we go along. But that's what had to happen, and that's what indeed did happen. And I'm going to start sort of summing up and telling you guys what we've learned. And there's going to be only like 5 things. They're rather straightforward. First, if you can, I'll say start fresh. Don't do what we did. Don't believe that the baggage that you have sort of can help you in the future. If you can, sometimes it's a great baggage and sometimes you need it. But we really were there was sunk cost fallacy that we didn't realize what it was. And then we don't do that mistake. Everything you do, focus on enabling speed. Our problem was that some architecture choices and decisions were just not enabling the team to move fast, or at least fast enough. Do leverage managed services. The reason I like modern clouds is not only because I don't have to do much of infrastructure operations, I like that I can use services that are available there. Like that search that I mentioned, the Elasticsearch, our new search prototype, took us maybe 3 days. All in all, get documents sourced in, build webhooks to keep index up to date, throw an API in front of it, do all of that, and launch 3 days. Now, we didn't launch it live in 3 days. It took us maybe like 2 more weeks after that to launch it live. But it was so quick because of how little we had to do around Elastic, for example. Thinking APIs versus backends, you have APIs. We have maybe 50, maybe 60 APIs. There's only a few services behind them. But when you think in APIs, when the API plane is clean and you see all of them, you can start changing what happens behind it. And it also changes how you approach building them. I think of my API consumers. I don't have them yet other than the front ends that I mentioned, but they'll come. Our ecosystem is growing. Our API is ready already to sort of app-to-app integrations if you need to, because our API plane is a lot more capable. And I guess finally, we rarely build individual apps. We build ecosystems. And thinking about that as an ecosystem will help you make more sustainable technology choices. And basically, with that, I'm done. So thank you very much. I'm open for questions, and let's see, do we take them here or do I go to that other room to take questions?
That was a brilliant presentation, Pavel. Thank you very much. I know it's quite early where you are, but hopefully you will be able to visit EPAM offices in Lithuania.
Oh yeah, I hope so too. I've been to Lithuania a couple of times, but it was a long time ago during my childhood.
Wow. Nice.
Soviet times. I don't think I've been to Lithuania after 91.
Oh, it has changed a lot. So it has changed a lot. So as Pink Floyd said, really wish you were here.
Okay.